Thanks, Peter. Good to see everybody. So yeah, welcome. It's a slightly different Beltec, but should be good as well. So I'm looking forward to it. As Peter said, we're going to have a drill down into what it's like to do cloud native development. But before we get started, I'm Martin Woodward. If you want to get hold of me, you can send me abuse at Twitter at Martin Woodward, or get me GitHub Martin Woodward as well. So I live just up the road. I'm up here in sunny Randallstown. It's not particularly sunny today, but there we go. Never mind. So, but like Peter says, as you can tell from my accent, I'm a bit of a blow-in, but I live on the road up to Ballymena, so I don't like spending money if I don't have to. And what we're going to drill into today is talk about how cloud native development happens and sort of ways you can do this and maximize what you do with all your spend. If we look at some trends, what do we mean by cloud native? Often when you look at the cloud native technologies, you can see that there's an abstraction of the underlying platform. As Peter mentioned yesterday, Mark was showing us the Azure Search stuff, which is actually, built on backend, which is all like Elasticsearch and a bunch of other things, and setting up loads of indexes and blah, blah, blah. And it can, be a pain. But this abstraction of the underlying platforms and technologies and giving you an API to code against is one of the sort of fundamentals things that we see in a lot of these new cloud technologies. Another example would be, say, Kubernetes and the way that it's, abstracting from you the orchestration of all these Docker containers across multiple servers and doing all that across different serverless and, not quite serverless environments. And then if we go full serverless with something like Lambda or Azure Functions and things like that, then, you have complete abstraction of this underlying orchestration layer, and you just go develop against it. All amazing stuff, and all things that a lot of us are starting to use to develop. The other thing that we see with these cloud native tools is a notion of dynamic scaling. So rather than requiring, massive spin up time, rather than going to Dell or HP or somebody and ordering hardware, rack mounting the hardware, getting up in your data center, making sure you've got power and bandwidth into the data center, you can dynamically scale your applications in seconds to meet load. Again, that's great for cost reductions because you can, scale up when you need it and scale back down as you do that as well. With traffic spikes, you need more resources. When it comes up to end of tax season, when it comes to Christmas and things, or, just recently during COVID, as we've seen more and more people piling into the cloud and working from home, and we're having to pile more and more resources up on to support those people, we're able to just dynamically scale that. And again, that's a common trend that we see across all the cloud native technologies. And the final one, which is the one that appeals to the people from Ballymena especially, is that you only pay for what you use. Unlike virtual machines where you're paying for them all the time, or unlike your own hardware where you have to pay for it up front, you're only paying for a lot of those cloud native technologies like Kubernetes, like serverless, per transaction, or even Apache Search. So you're only doing that per transaction fee and for what you're using. And that's, again, a common trend that we're seeing across the whole industry there. And if you think about it from a cloud provider's point of view, that makes sense, because with dynamic scaling and because with, being able to abstract some of the underlying technology, they're able to only provide you the resources when you need them. And then when you don't need them, they're able to sell those resources on to somebody else and make money there. And so you're paying basically for electrons, for, compute time. And that allows you to, you get the cost benefits, but also the cloud provider is able to maximize the use of the hardware that they have. Unlike with a VM, they have to give you the whole VM and just allocate it to you, so they can't pass those savings on. Now, if we look at a lot of the cloud native companies that we see out there, like Spotify or, Uber and all these sorts of people, we actually see a lot of them heavily invested in terms of DevOps as a process and, being able to get people closer together in the development platform. So if we look at the sort of key practices we're seeing around DevOps in the cloud, we see obviously this notion of continuously improving, so continuously getting better. shipping. Ship to learn is what we say here at GitHub. So, just go ship something, learn from it, and then iterate and keep improving. We see, obviously, collaboration is a key part of DevOps processes and principles. The clues in the name, Dev and Ops. So obviously development and operations are talking better together. But it's not just Dev and Ops, it's Dev, Ops and customers and the security team and the compliance people and, all the stakeholders involved in that project are working close together, and there's improved collaboration there. We do see significantly more workflow automation with teams that are highly performing in terms of DevOps. But don't make that think that DevOps is workflow automation. A lot of times you think what DevOps is, and you might think of CI, you might think of, using Terraform to push out to multiple cloud providers or, all that sort of stuff. That's done in a lot of people that are practicing DevOps because they're also cloud native and they're using a lot of these technologies. But the workflow automation isn't the only thing. That's just part of the whole picture. We're going to spend most of our time talking about some of that automation here today. But anyway, that's not the whole part of DevOps. And then security and compliance is the final thing. Sorry, not the final thing, is the next thing you need to make sure you do. Just because you're shipping, just because you're constantly updating doesn't mean you can forget about doing compliance anymore. It means you have to bake those tools earlier in your development process, shift left with your security tooling to make it easier for your DevOps team to be able to bake security and compliance processes into everything that they do. And again, that's common in cloud native development practices. And then the final thing is obviously monitoring and learning. It's no good just shipping quicker if you don't learn quicker as well. And we see lots of teams, getting out there, being able to speed up their development processes. But then when they come back, you sort of ask, so, did we make the system better or worse? How are we doing? And you'll see that they don't know. And you sort of, I don't know, we're not going to learn for 6 months until we start to see the revenue benefits from this. So what we do is we always make sure we invest heavily in terms of monitoring and learning so you can have instant access to know if you're making things better or worse. If you go into one of these cloud native startups, you'll see dashboards all across the walls that show exactly what's happening today, not just in terms of load, but also in terms of things like revenue, in terms of people signing up for the website, whereabouts they're getting in the processes. And you'll see them looking at a lot of leading indicators. These leading indicators, so the change in signups, the change in revenue, or the change in transactions per minute. Those are the leading indicators, which are good sort of KPIs, good OKRs to be monitoring, because they're the things that change first and tell you which direction that you're going. Are you going up or down? Have you made things better or worse? So those are the things that we kind of see when we go into these cloud native companies. And we're all, even in like banks and insurance companies and everything else, we're starting to adopt a lot of these technologies and a lot of these processes. But then when we look and we sort of say, let's get a new development environment set up. How's our development environment changed in the past 10 years? Quite often it's not changed that much at all. If you talk to the average team, and you want to set up a build server or something like that, then this is often the experience that you have. You're sort of holding your head, trying to plug in some new ports in the server room in the back of the office, trying to stand up a new build server, trying to get a build environment configured. Maybe you're running on a box under somebody's desk and nobody really realizes it. Even getting dev boxes, the number of times that you're onboarding new engineers, and you have to get a new laptop ordered for them, and you can't buy webcams because everybody's out of stock of webcams now. It's just, it can be a bit of a pain, and it feels that our development environment is lagging from our production environments in terms of being fully cloud native. So what I wanted to do today was kind of talk a little bit about some of the tools and technologies that we provide over at GitHub to help people be cloud native, but there are other providers as well, and we'll drill into some of that sort of stuff. So the first one is around getting a serverless CI environment configured. You know, oftentimes people are using Jenkins or something like this to get set up, but there are a number of providers of fully serverless CI environments. There's Circle CI, there's Travis, there's Azure Pipelines built into Azure, but there's also GitHub Actions, which is what we have natively built into GitHub. And an environment such as GitHub Actions gives you the ability to, build. So we provide Linux, Mac, and Windows builds, just fully configuration as code. You can do, full matrix build. You can build across lots of different platforms. There's a built-in, secret store, so you can do that. And you can have the ability to run runners locally if you want. But we take care of all the hosting of your build servers for you. So you can just provide us with a configuration file, and then we can go do the building. That configuration file lives with the code, so that when you want to then stand up a new build environment, the code comes with the build environment. It allows you to automate any workflow, so it's not just doing CI/CD, but maybe if somebody creates an issue, you want to run some automation. I've got a team at one of my customers that when they want to stand up a new environment in Azure, they actually create an issue, fill out an issue template with all the things that they want, hit submit, they post the issue. Once that issue is approved, then automation in GitHub Actions comes along, creates all the ARM templates, creates all the Terraform scripts and what have you, deploys that environment, and then drops a URL back into the issue that says, here's your QA environment up and running, off you go. So that's fantastic. That now you can sort of see how you can start to automate any workflows, not just CI processes, but maybe even dev, production, dev and test sort of environments. You can start to automate any of these workflows. Just a quick drill down, as I've got a bit of time, onto how these action runners actually work. So they run in the cloud. We have it's a full cloud host environment with a bunch of VMs and containers and all that sort of stuff. But locally, if you want to run something that talks inside your firewall, then you can actually run your own local runner on your own infrastructure if you don't want to go fully serverless, and that allows you to access into your network as well. Right, the next thing I want to talk about is that's dev, that's build. What about, doing your coding on your machine? If you think about a typical environment, you have to go get configured. You have to order a laptop, order a dev box, get it installed, get all the prerequisites installed, fire up the README. Hopefully somebody's documented it and told you what prerequisites you need, clone all the source code down, run some magic to get the script set up, and then finally run build, see why it doesn't work, and get going. How long does it take you to get a developer up and running in your environment? Our goal is to have developers be productive their first day in their team, so they come in, they do some training, and then they can have code running in the hands of customers by the time they finish their first day on the job here at GitHub. And that's what we're trying to help a lot of our customers do as well. So we've introduced a thing called code spaces, which is the ability to have a full container-based development environment running right there inside of the browser. So you don't need to go set up a dev box, anything like that. You can just go run it. It's actually handy for a bunch of things, including not just, setting up brand new environments, but because it's configuration as code stored alongside the code, you can set up a dev environment that, and have it stored in the code for a legacy application. And then, maybe it's something that's not being changed, nobody's touching it for a few months, and then all of a sudden you get a support ticket and you've got to go, dev on this machine again. No longer do you need to reset up all the environment, get rid of the version of Visual Studio or whatever you were using, or the versions of .NET or Java or whatever it is that you were doing. Actually, you can go in, stand up, reinstantiate this environment, rehydrate it, go play with it, go do some coding, and then shut it back down again and move on after you fix that bug. So let's go have a quick play with some of this stuff. So if I jump in here, hopefully you can see my development environment. So this is just a simple project I've got here. I'm just going to show you the code stuff first. So I'm going to come in, let me just do this, hit refresh. Just let it shut down a second while I was just chatting there. Right then, so I'm going to come in here and I'm going to open with code spaces. So I'm going to open this project in a full inside of my browser, completely configured. This is running Visual Studio Code inside of the browser, but it's a full instance with all the extensions, all the plugins, all that sort of thing. And we can see we've got some messages here. and we have, just a simple Razor Pages file there. But it's a full development environment. So if I come in and I change the first message, so, let's make this the 09 version of Hello World. So let's just do, how's about you? There we go. And then we'll have that. We'll save it. And then I can come in and I can just debug it. So I'm going to, come in and we can debug that. Now, it's smart enough to recognize once I run the debug, it's running all the compilation, running all the builds. As soon as it sees me trying to open a port on localhost, I've set up port forwarding, and I'll show you where I've configured that. And it shows me trying to access localhost, and it'll actually map localhost over SSL over to a port that's authenticated, so only I can access it. And then it'll come in here and it'll run my application for me. And we'll see it's, oh, okay, would you like a cup of tea? So that's not what I was expecting. So if I come back in here, that's the second message, and I look and, right, well, I'm not quite sure what's going on. So I'm going to hit debug, and then I'm going to come back into this page. I'm going to hit refresh, and I'm going to go back into my code editor window, and I can see it's now paused on this line. Message is 1. Okay, well, this is looking okay so far. Let's just step over that. And we'll see messages contains, would you like tea? Okay, look at my array. It's a classic, I've done my array wrong. It should be array 1 rather than array 0 rather than array 1. So I'm just going to stop the code execution. I'm going to hit 0 there. And then I'm going to save that. And now I'm fairly happy this is going to run. So I'm just going to commit these changes into code. So I'm going to say make fixes. And I'm going to check those in. I'm going to commit those. Notice I'm committing both these files at the same time. And I'm just going to push them back to the server, push them back to my main branch on my server. And then while that's pushing, I'm going to jump back over and go look at the code. And I can see in here that we have, if I'm just going to quickly hit refresh, I should be able to see. Last change 22 seconds ago. Fantastic. So that's cool. I've made my changes. But what about all my builds and all that sort of thing? So if I come in and look at my environment, if I go to actions, I can actually see I've got CI set up, and I've also got a few other things going on here. So we can see my CI builds running to make fixes. And if I look at that, I can see it's already built on Ubuntu. It's already built on Linux. And then it's going to be building on Windows and the Mac in parallel. So I don't have to go buy a fancy Mac, from the Apple Store. One's already here for me. The build's already finished on Mac. And it's run all the tests and everything else. I can go look at what it's done. And then the build's still running on Windows. When that completes, then I can go release that code. If I want to release that code here, I'm just going to quickly do a new release. So let's just quickly release the code. So I'm going to create a new release, and I'm going to say, I'm going to tag it with production/Beltec. And then I'm going to say Beltec release. And then come in here, hit publish release. So now when I've created, because actions allow you to automate on any part of the workflow, not just CI/CD, as soon as I created this release, it's triggered a new, he says, it should have triggered. What did I do wrong there? Okay, make fixes. Yeah, there we go. It's triggered a new release of this application, and it's pushing this code now up into Azure, and we can see that running. Right, quickly, let's have a quick look in here, and we will see how we configure this. So if we go in, and the first thing that we'll do is how did I configure my development environment? That all lives in a folder called dev container, and you see dev container.json. In there, it's configured my Docker file that I want to use, which has got my environment set up, and what extensions I want installed, and then what ports I want forwarded. So that's pretty straightforward. And then your Docker file is just a straightforward Docker file. It's coming in here. It's told it which image I want to use as a base, and then it's running a setup script after it's installed. And then over in my setup script, I'm doing a bit of magic to go get the environment exactly configured how I needed it. So this is a completely reusable, rehydrated development environment that everybody on the team can share and use. And you see it's just coming in, and I'm doing some scripts, running some apt-get stuff to get everything pre-installed. And if you think about all the instructions you have to follow as a new dev on the team to get set up, the fact that you can store all these, make them as code and make them reusable is amazing. You can run these dev containers locally as well. So if you have a more powerful machine and you want to run it locally, then you can totally just go do that and run it. It's just a container. So we're going to come back into here, and then I'll look at my workflows just quickly. I've got 3 workflows configured. I have code analysis because remember I said about shifting security left. I want to, every time somebody commits code into my code base, I want to scan it for vulnerabilities. So that's what that's doing there, using a thing called CodeQL, and that's running in the security tab. You can go look at those results. The CI build is the one that's running on every commit. So every time I push to main, or every time I do a new release branch, then it's going to come in here and it's going to run on Ubuntu, Windows, Mac OS. And then for every operating system, it's going to do exactly the same thing, build, test. And then finally, if I look over here and look at publish, this is a simple one. It's going to, every time I push, I create a new release tag called production / something or other. It's going to get the code, publish the code, and then deploy it. So that's deploying it to this website here. And so hopefully, if I just do Command C, coming here, you should be able to go do this from home as well. If you go to .NET Mona, how's about you? There we go. Fantastic. Great. So then if I just jump back to the slides, that was a demo. Now, the good thing about doing serverless development, our parent company, Microsoft, has a commitment to be carbon negative by 2030 and to take all of the carbon that they've put in the atmosphere since the company was founded back in 1975, is it? They've got the commitment to take all that carbon and pull it out of the environment by 2050. And as this goes, it's obviously we're already, our data centers are already greener than your data center kind of thing. The data centers where all this environment running is completely carbon neutral already. And they're getting the entire supply chain carbon negative is where we're heading to. And that's a lot better than leaving a machine switched on in the office or, under your desk or something like that. And obviously supports remote work a lot better as well. So by investing in these serverless technologies and some of these cloud native technologies, you're able to come in and reduce the amount of server load that you're using. You're allowed to reuse servers because the cloud provider can come in and reuse what you're doing and move it on and give it to the next customer. And that allows you to save a bunch of time, save a bunch of effort. It's more cost effective for you as a development team. But when was the last time you were in your stand-up and you actually sat down and thought, what is the most carbon, lowest carbon impact thing we can do to provide this environment to you? And that's what using serverless technologies, using a lot of the cloud native technologies actually enables you to do, is to reduce your carbon input and your carbon impact, and have a much better, footprint on the environment and hopefully become a lot more greener in your own development processes as well. Right then, so we started a little bit early, so I'm actually fairly ready. I can dig in a little bit more, but if Peter's ready and gives me the thumbs up, I can pass back to Peter if you want. So I'm just going to check now. But otherwise, we can go on. Thank you very much.